Hello, my name is Andy, and I'm with ElitePrep. I specialize in biology and chemistry. Today, we want to take a look at one of the questions from AP Chemistry. So first, identify the hybridization of the valence orbitals of either carbon atoms in the oxalate ion. So in order to solve this question, we have to count how many electron-dense areas are around each carbon. There are 1, 2, 3 electron-dense areas around each carbon. And 3 most common hybridization of the valence orbitals are sp, sp2, and sp3. sp hybridization occurs when there are 2 electron-dense areas around the center atom. sp2 hybridization occurs when there are 3 electron-dense areas on the center atom, and sp3 hybridization occurs when there are 4 electron-dense areas around the center atom. So, if we take a look, there are 1, 2, 3 electron-dense areas around the center atom, in this case carbon, so the hybridization would be the sp2. Okay, let's move on to the next question. Silver oxalate is highly soluble in water. The value of the solubility product constant is given. Now, the first part asks for the expression for the constant. So the first step would be to write the reaction that occurs when the silver oxalate is dissolved in water. It's solid, dissolved in water, dissociates to become 2 silver ions and 1 oxalate ion. And because they're dissolved in water, we have aqueous instead of stable. Now, remember, for all equilibrium constants, including the solubility product constant, we do not include pure solids or liquids. Hence, for the expression for the solubility product constant, we have equal to the concentration of the silver ion squared times the concentration of the oxalate ion. Okay. The reason why there's a exponent of 2 and then a hidden exponent of 1 for each of the product is because of the coefficients. Okay. So since there's coefficient of 2, the exponent here would be 2. Since there's going to be exponent of 1 here, it corresponds to coefficient of 1 in the front of the oxalate ion. Okay, so this would be our final answer for the solubility product constant for silver oxalate. Take a look at the next question. Calculate the molar solubility of silver oxalate in neutral distilled water. Okay, so here, in the previous question, we have the constant for the silver oxalate. And remember that for every 1 mole of silver oxalate, there's going to be 2 moles of the silver and 1 mole of the oxalate ions. And we'll carry down the exponents. And so we have the constant is now equal to this term. And if we do some algebra here, we have 4s squared times s. And also now ksp is equal to 4s cubed. And once again, the value of the solubility product constant is given here. So we can write that down. Okay. And when we use the algebra, the molar solubility comes out to be 1.11 times 10 to the negative 4 molarity. And this would be our answer. Okay. Finally, we have one more question left. Okay. So this question is very long. So what I recommend is that you stop, you pause and read, and then unpause once you're done reading, okay? So this reaction is an acid and base reaction. So what we have is, we have the silver oxalate, okay, react with the acid to form, and this is going to be our acid and base reaction because we have a transfer of the hydrogen ion, okay? And this is also here a double replacement reaction, as can be seen here. And we can also balance the reaction, okay, like so. Now what we're going to do is we're going to write an net ionic equation, okay? And in net ionic equation, we only include the species that are actually undergoing the change. So in this case, what we're going to do is we're going to write C2O4 2 minus plus 2H plus, okay, goes to H2 C2O4, okay? And in this case, what happens is the ClO4 ion and the silver ions they do not change the state, and so we do not include them in the net ion equation. And these are just called spectator ions. So this would be our final answer. Well, there you have it. So that was AP Chemistry, question number 7 from the 2022 exam. And thank you very much for joining.